Let's start with the random variables, and we will focus on two major concepts. First, what's the difference between discrete and continuous random variables? Second, what's the probability distribution of a random variable? In particular, the expected value, variance, and standard deviation of a random variable. So let us look at some examples to get a sense about what is a random variable. A random variable is a numerical description of the outcome of an experiment. For instance, if the experiment is to make 100 sales calls, and we define the random variable as the number of sales among the 100 calls, then we know this random variable can take values of 0 or 1 or 2 or 3 and so on. Similarly, if we define the experiment as flipping a coin for 100 times and define the random variable as the proportion of heads we get from the experiment, then this random variable value can range from 0 to 100%. As we mentioned earlier, there are two types of random variables, discrete and continuous. A discrete random variable can take on a countable number of values. For example, suppose we define the experiment to be randomly picking one person from the population and ask about his or her family size. And we define the random variables to be the number of dependents reported on the tax return. The possible value for this variable is countable. So it is a discrete random variable. In the second example on the bottom, we define the experiment to be randomly picking one student from our class and ask about that student's travel time from home to the university's main campus. Suppose that the smallest value is 5 minutes since some students live close by. Then what is the next possible value? Is it 5.1 minutes, 5.01 minutes, or 5.001 minutes? We actually cannot identify the second or third or any other values of the random variable. Therefore, we cannot count the number of values for this continuous random variable. In summary, discrete random variables are usually counts, and continuous random variables are usually measures such as length, time, height, and so on. Let's take a look at one example. If we can randomly pick one car from the 7th Street parking ramp and define the following random variables. Are they discrete or continuous? Think about the answers on your own, and the answer will show up on the slide in about 15 seconds. Next, I want to use an example to talk about why random variables are useful in solving decision analysis problems. In this example, we are playing a game. You roll a fair die, and if you get a 5 or a 6, then I will pay you $10. However, if you get a number that is less than or equal to 4, then you need to pay me $4. So do you think this is a good deal to play the game? Some of you might start to link the game to probabilities. If we define the random variable x to be the payoff of this game, then we know that x can take a value of $10 with probability 0.3333 and take a value of minus $4 with probability 0.6667. With the notion of random variables, We can then work on further analysis about whether this game is worth playing. So how do we do it? Well, we will need to use the concept about the distribution of a random variable. In particular, we will utilize the concepts about expected value, variance, and standard deviation of a random variable. In this class, we will mostly deal with discrete random variables. What is the distribution of a random variable? Generally speaking, it is a description of how likely each value of a random variable will occur. For example, suppose there are 100 students in a business class. Among them, 30 students have no sibling, 50 students have one sibling, and 20 students have two siblings. Now, we randomly pick one student from the class and define X to be the number of siblings that the selected student has. Then, the distribution of X is as follows. X can take values of 0, 1, and 2, and we use probabilities to describe the likelihood of each number. Sometimes we can also use a graph to visualize the distribution of a random variable. In other words, the distribution of a random variable gives the information about how likely each possible value of that random variable will occur. With the concepts of a random variable's distribution, we are now ready to talk about the mean value of a random variable. Let's use the same example in which we are interested in the number of siblings a student has. Suppose we want to calculate the average numbers of siblings for these class students. We can then first find the total number of siblings for all students. 30 students have 0 siblings, 50 students have 1 sibling, and 20 students have 2 siblings. Sum up those numbers and then divide it by 100 students. Before you jump to the conclusion and find a number, let's do some manipulation of this formula. We can first rearrange and separate the numbers by the @ sign. Next, we pull out the number of siblings in each term. Then, we translate the fraction numbers to their decimal format. And we can get the answer. Now, if we observe the second last line of the equation, we can see that the average number is calculated by the value of the possible outcomes and how likely each outcome will occur. This is actually the concept of expected value, which is the average of all possible values of a random variable can take on. In the formula for calculating the expected value of a random variable, you can see that we want to find the possible values of a random variable, weight them by the probability, and add them up. In this example, X can be 0, 1, or 2, with probability 0.3, 0.5, and 0.2 respectively. We can calculate the product of each value and the corresponding probability. Then, we sum up these numbers to get the expected value of X. In the next example, try calculating the expected payoff of the game on your own. The next concept I want to talk about is the spread of a random variable. So why do we care about the spread? It is because average does not always tell us the whole story. Let's see the first example. In the second example, you are considering to invest in one of the following two stocks, and you know that both of them yield 10% average yearly returns. However, there is some variability in each year's performance. Most people would prefer stock A over stock B because the stock A's return is more stable. So how do we measure the spreads of a random variable? We use variance. Variance can be viewed as the average square distance between sample points and the expected value. It is calculated as the weighted average of the square distance of the possible values from the mean. And the weight is determined by how likely each value will occur. The higher the variance, the more spread out the possible values of the random variable. Let's look at the same sibling example. We want to calculate the variance of the number of siblings for the students in the class. First, we can calculate the expected number of siblings. Then, we can find the distance between each possible value of x and the expected value. Then, we calculate the square distance for each value away from the mean. Weigh them by the corresponding probabilities, and then sum them up to get the variance. In the next example, try calculating the variance of the payoff of the game on your own. Finally, we also want to talk about the concept of standard deviation. The notation on the left-hand side of the equation is pronounced as sigma. Standard deviation is the square root of the variance. It also measures the spread of the possible outcomes of the random variable. The higher the standard deviation, the more spread out of the value of a random variable. For example, if a random variable x variance is 36, then the standard deviation of x is 6. Now, let's use two examples to conclude this module. Expected value is useful when we compare different options that involve uncertainties. If you are choosing between lottery A and lottery B, which one would you prefer? If we use expected value as the selection criteria, then we can calculate the expected value for option A and option B. And we will find that option A has a higher expected value. So what does it mean? It means that if we can play the lottery for many times, the average payoff for lottery A is higher than the average payoff for lottery B. In the next example, we want to use standard deviation as our decision criterion. Which supplier do you think is more reliable? The answer is B because the defect rate standard deviation is smaller for B.